Yes, we can.
Yes.
Gio, can you turn off your microphone? Thank you.
So, hello everybody. This is Python course, and I'm Nastan. I'm a PhD student under the supervision of Adrian Montino in ETRO-VUB. You can reach me via this email address. Actually, now I'm using my VUB email address to join this meeting, but the email address that I usually check is the email address on ETRO-VUB domain. I'm a PhD candidate in ETRO-VUB, but I'm also a C++ professional programmer because I have 4 years of experience in a company in Iran. But this course is not about C++, it's about Python, and I do have experience in Python because in my PhD, I can say most of the time I'm using Python, not C++ or other languages. So actually, this is the main reason that I'm teaching Python, because I think with this course, I can also learn. And so it's more than just a catch-up course. It's and it depends on your interest. If you want to know more, I can teach more. I can bring up many advanced topics, but it also covers very beginner level comments. So it will start from the very beginning of Python till wherever you want to go. But I'm not sure if, since this course doesn't have any score for you, so the only thing that will motivate you to continue attending this course is your motivation. You should know that you will need that for your master thesis at least. I mean, you may need this Python for the other courses, but for sure you will need it for your master thesis. And if you want to continue to do your study, to do a PhD, for sure you will need Python. Even if I was a C++ programmer, I had to learn Python because all the resources on the internet are on Python, because it's a beginner language, so all the researcher can use that easily and implement their ideas very fast. While if they want to use it in while they want to implement that in C++ or Java or other difficult languages, it will take time. So I can say that Python is necessary for you to learn. Also, it's good if you want to be a professional Python programmer in the industry. It's not a language like MATLAB that is used only for researchers. It's also for people who are working in the industry. That's why I'm trying to learn that in more depth. Okay. Python is developed between 85 and 90. Python 1 is released in 94, and Python 2 is developed in 2000. And latest edition of Python 2 is 2.7.11. Actually, the developer of Python is not supporting this version of Python anymore. But still, there are many codes on the internet that are working only with Python 2. But in this course, we will cover Python 3 because it's more advanced and new, so it's better to learn Python 3. Python 3 is released in 2008, and it's already, it's changing every time, and every month you will see a new version of that. Python 3 is not backward compatible with Python 2. it means that if you have a code implemented in Python 2, you cannot run it with Python 3. You may not be able to run it with Python 3. We will see why, because there are some commands that are not supported in Python 3 anymore, while it was in Python 2. The emphasis in Python 3 had been on the removal of duplicate programming constructs and modules, so that there should be one and preferably only one obvious way to do it. That was their theory, that was their belief, and why Python 3 is not backward compatible with Python 2. But in fact, there are some duplicates programming constructs in Python 3. And you know, if you have experience with C++, you already know that in C++, the new compilers are backward compatible with the old compilers. But this is not the case with Python 3. And as a C++ programmer, I'm more biased to C++. So I may criticize Python 3 during this course, and you will notice that I'm more biased. You will see why I say that it's not very interesting that Python 3 is not backward compatible with Python 2. But to give you some motivation to learn Python, you should know that Python has some advantages. It's a beginner language. Python is a great language for the beginner level programmers and supports the development of a wide range of applications, from simple text processing to WW browsers to games. So it's not only it's used in academic environments, it's also used in the industry. And its interpreter, what does it mean? Python is processed at runtime by the interpreter. You do not need to compile your program before executing it. In C++, sorry, in C++ and in Java or other languages similar to that, you have a compiler. You first build your program, link your program, and then you will run it. So with builder and linker, you will see your syntax errors, if you have any, and you will see your link errors. Then you can run your code. So there, in the running stage, you may have some bugs, but there is not any syntax error there. But with Python, you have interpreter. And what's the difference? If you have an interpreter, you do not have the builder and the linker stage. So you won't see the error if you have, for example, 1,000 lines of code. If you have a syntax error in the line 1,000, you won't see that till your interpreter tries to run that line. So all the previous lines will be run, and then in the line 1,000, you will see that you have an error and your program will crash. So this is the difference. But if you have a C++ or other languages, you could not be able to run your whole program if you have an error in any part of your program. And Python is like MATLAB, not exactly like that, but it's like in MATLAB you can work interactively with your interpreter. You can write a command in the console part of MATLAB. Usually it's in the bottom part of your window, and you can see run your commands one by one, and you can interact with your interpreter. This is also the case in Python. So you can run Python and run your code line by line. You will see later how. But at the same time, you can also run a piece of code which is written in a Python file. It's object-oriented. So as a programmer, it's really important nowadays to write your code with the techniques that you have in object-oriented domain. So Python supports that. And actually everything in Python is an object, and you will see later. So it's easy to learn, easy to read, easy to maintain. There is a broad standard library, interactive mode, as I said, it's portable, extendable, it has a large, it supports many different databases, it supports GUI programming, and it's scalable. You can write a small piece of code in the shell of your operating system, or you can develop a very large program. And in C++, in Java, you usually worried about your memory. You are responsible to take care of the memory allocations. But in Python, like C#, if you have any experience with C#, you know that there is a garbage collection, an automatic garbage collection. What does it mean? It means that you don't care about the memory. But we can say this is just something that Python tries to make ready for the programmer, that the programmer doesn't need to think about the memory. But in fact, if you want to write a program, you will have to learn more about the memory, even when it is Python, even when it has a garbage collection. It means that if you have some objects, if you create some objects in your memory, the Python interpreter will release them for you, and you don't need to delete them, like pointers that you have in C++. This is also the case in C#. C# is another language that is trying to have C++, but in a more easy way. Python can be easily integrated with C++ and other languages. So now I'm going to show you some differences between Python 3 and Python 2. This is not all differences that you can see, but these are the common differences when you, for example, when you write a code in Python 2, or you download a code in Python, which is written in Python 2, and you want to run it in, with a Python 3 interpreter, you will see these differences and you have to fix them. So I'm just going to show you the common differences here. But before that, I want to ask you, did you get all the characteristics of Python and the differences of that with between the Python and the other languages, the one that I just told you? I can see. Is it clear till now?
Yes.
Okay.
It's clear for me.
Okay, so I will continue. So, for example, the print function in Python 2 can have parentheses or not. So it's acceptable. Do not write parentheses when you are using print command in Python 2. But in Python 3, it's obligatory to put those parentheses. Or in Python, in both of the Python 2 and Python 3, you have to use, if you use print function, at the end of the thing that you print, you will see a new line. So it will go to the new line to print the other things. But you can suppress this new line in Python 2 with comma. But in Python 3, you have another argument that you can define what is the end of my text. the thing, for example, here x will be printed, and I'm saying that after that I don't need a new line. I want to just have a space. So this is the difference in the print function. And for the input, you can, when you want to ask the user to enter a value or a string for you, you use input function. And here, in Python 2, if you enter a number, it will consider it as a number. It will will be treated as a number, like here. But in Python 3, if you enter a number or a text like this, in both cases, Python 3 will be treated will treat this data, will consider this data as a string data. But in Python 2, if you want to consider that as a string, you have to put it in quotation. In Python 2, you have another function which is raw input, and in if you enter, it's like raw input is like input in Python 3. So it's similar to that one. If you enter 10 or between two quotation, in both cases, it will be considered as, it will be regarded as a string. But you don't have raw input in Python 3, as they claim that they want to just keep the one that is preferred. Integer division. In Python 2, this will lead to 1. In Python 3, this will lead to 1.5. Okay, you may have a code which is written, a piece of code which is written in Python 2. Now you want to have some features that is provided in, some features that are provided in Python 3. What should you do? You can use future module to have those features that are available in Python 3, but you are using Python 2 compiler. So why they are doing this? I said that Python 3 is not backward compatible. So if you write a code in Python 2, you cannot run it with Python 3 if you use some commands that are not supported in Python 3. So you have two choices. You can either change your code in Python 2 to make it compatible with Python 3, or you can still use Python 2 compiler to run your code. But if you need some features from Python 2, you can use future module inside Python 2 compiler to have those features from Python 3. To my idea, it's very ugly to do something like this. And the problem comes from the fact that Python 3 is not backward compatible. This is not the case with other languages, but this is how they develop their language. And about Unicode representation, in Python 3, all the strings are encoded using as Unicode. But in Python 2, if the strings are encoded as ASCII, unless you put U before the string, then it would be Unicode. But why Unicode is useful? For example, you are going to write a program that is going to support Arabic languages. Those letters are not in ASCII, but they are in Unicode. So you may not notice the difference, but this is actually a good thing to have Unicode instead of ASCII. You can search about Unicode and ASCII to learn more about that, but this is not related to this course. That's why I don't go in depth in this topic. Sorry. Xrange function has been removed in Python 3. You will see later in this course what is range and what it does in more depth. But now I'm just going to tell you what is the difference, what's between Python 2 and Python 3. In Python 2, range returns a list, and xRange returns an object that will only generate the items in the range when needed. In Python 3, the range function is removed, like what we saw for input. Raw input is removed, and input has been removed, and raw input has been renamed to input. This is also the case with range and xRange. Range function here is removed, and xRange has been renamed as range. And also in Python 3.2 and later, the range object supports slicing, which is not the case in Python 2. So if you, for example, have a piece of code which is written in Python 2, and you are using a Python 3 compiler, and you saw an error on your xRange, you have to rename it with range. The only thing that you need to do to be able to run it with Python 3. And raise exception here. Again, in Python 2, you don't need to write a parenthesis, you put a comma, but in Python 3, this is also accepted in Python 2, but in Python 3, this will lead to a syntax error, but this one is the only way that you can raise an exception. We will also talk about exception in the other lessons. And also here, if you want to have an argument for your exception, this is the syntax in Python 2, and this is the syntax in Python 3. And here, next function and next method. This one, by this one, you are creating a generator object. Again, we will talk about that in the next lessons. And this one is allowed in Python 2 and Python 3, but this one is only allowed in Python 2 and raises an attribute error in Python 3. Why it's an attribute error? Because next is a method. We can say that methods are just an attribute of this object. And when it's removed, it means that it's not this class doesn't have this method anymore in Python 3. Okay, a good thing that exists in Python 3 is 223.py script, which you can find it usually in tools scripts folder of your Python installation folder. And what does it do? It reads Python 2 source code and applies a series of fixers to transform it into a valid Python 3 code. So since Python 3 is not backward compatible, they finally provided a Python code to translate a Python 2 code to a Python 3 source code. And if you run it, for example, run this one in this, you will see the result will be this one. To install and test Python and Pycharm, I prepared a document for you that gives some instructions to be able easily for you to make it easy for you to install Python and Pycharm. You can find it here. After this lesson, I will share it with you. This is the document. Actually, I gathered them from, integrated all of them from different sources of different internet sources. So, but this is something that you can use it for all the operating system. Not all, I mean Mac, Windows, and Ubuntu. So first, it's just Pycharm. It explains what is Pycharm, and then you should if you have a Mac or a Windows system, you will first install Python and then go to this step to install Pycharm. If you have Windows, you will go here. So don't duplicate. I mean, don't redo the what you did for example, for Mac, also for Windows. So you should just follow the instructions based on the operating system that you have. And if you have if your operating system is Ubuntu, you will go to this section, and after all, you need to test your Pycharm. And to test your Pycharm, you will go to this. You will see that there are some screenshots of every steps. I hope you won't have any problem while you are installing them. But if you have any next lessons, we can talk about that to try to solve the errors. And what is Pycharm? Pycharm is an IDE which is used very commonly for Python. For example, for C++, Qt Creator, or Visual Studio are the most common used IDEs, but in for Python, usually we use Pycharm, which is a cross-platform software, and you can use it in different operating systems. For the moment, you can, if you don't have Python or Pycharm, you can use some online interpreters. Two of them, I suggest two of them here, but there are more than this. For example, for this one, you can, when you run your code in the online interpreter, you can see at the end how much time does it take, and how much time and how much memory it takes. And for this one, this one has more a colored way of displaying your code. So I can now, okay, let's see, share these two with you in the chats. I guess you can give it a look. Let me see. Chat. I think now you can see them in the chat section. Okay, thanks. So we are going to start with basic syntax of Python language. So we said that Python is an interactive language. So we can run we can communicate or interact with Python in three different ways. First, it has interactive mode programming. We open the command prompt, type Python 3, py, or Python, depending on the version of Python you have, and then it will show something like this to us. Now here, I can easily write print hello Python or some other things. And every command that I enter, like how we interact with command prompts, will be run with Python interpreter. The other way is that to write a simple Python program in a script and save it in a Python file. The extension of Python files is .py. Then you can go to your command prompt of your PC. All the operating system has have a command prompt. I think you are already familiar with that. So then you can write Python and the name of your Python file there to be able to run that script. And another way to execute a Python script in Linux systems, in Linux operating system, is to run this this command. This makes Python file an executable file. And then just by the next command, you can run your Python file. As I just said, you can also use IDEs. The Pycharm Ide also provides these two methods. Let me show you here. Yeah, here. This is a Pycharm Ide, a screenshot of Pycharm Ide. You write your script here, or you can go to this section, Python console, to be able to write some lines of code. So Pycharm provides you two ways of working with Python interpreter, either via Python console or just by running these lines of code in a script file. But when once you install your Pycharm in the next lessons, we will talk more about Pycharm and see how we can work with Pycharm. But for now, you can only use online interpreters. So what is a Python identifier? It's a name which is used to identify a variable, function, class, module, or other objects. An identifier starts with a letter A to Z or lowercase of that, or an underscore followed by 0 or more letters, underscores, and digits, like any other languages. But it's case sensitive. So if you, for example, define a variable A with capital letter, it's different from another variable that you define with A with which is lowercase. Python follows naming conventions. What is naming conventions? In every language, we can say even in some, it is different between the different companies, that they use naming conventions for themselves to be able to recognize the objects, the role of the objects, just by reading the code. For example, I can open my script in a notepad, and there is not any IDE to help me to find the role of my objects. If it is a class, if it is private, or if it is any other things. I should be able, if I don't have an IDE, I should be able to recognize them just by their naming conventions. Python has its own naming conventions, which is different from C++ or the other things. So class names it's not compulsory, but it's better to do that. The built-in function of Pythons follows these naming conventions, but you can write your code in any way that you like, but this is not good. It's better to follow the naming conventions that exist in Python interpreter. Class names starts with an uppercase letter. All other identifiers start with a lower case. So if you see there is an identifier which has an uppercase letters, you don't need to go to its definition, or you don't need to know anything more. You know that it's a class. unless the one that who wrote the code didn't follow the naming convention. That then you will have a problem. Starting an identifier with a single leading underscore indicates that the identifier is private. Starting an identifier with two leading underscore indicates that it's a strong private identifier. We will discuss about classes, private, and the rest in the next lessons. If the identifier also ends with two trailing underscores, the identifier is a language-defined special name. Again, we will discuss about them later. There, like any other languages, there are some reserved words. It means that you cannot use them as an identifier for your variables or your objects or any other objects that you have. So, for example, you cannot have a variable whose name is 4 because 4 is a reserved word for Python. Okay, if you have any experience with a programming language, in every programming language, there are some blocks of code. For example, you have if, you have for, you have any other structure, and every structure includes at least one block of code. So this is one block of code here. This is also one block of code here. But every language, each language has its own way of denoting, their own way of pointing to these blocks. For example, in C++ we use braces. In MATLAB we use AND, if, AND. In Visual Basic we use AND if, for example. And in Python we don't need to write anything to refer to denote these blocks of code. We only need to use indentation. So in Python, blocks of code are denoted by line indentation. The number of spaces in the indentation is variable, but all the statements within the block must be indented the same amount. Like here, this is one block of code, this is another block of code. This is also acceptable in Python, although they both are in the same structure. This is an if-else structure, but this block has different number of spaces and from the other block in the same structure. But this one is not acceptable because we said that all the statements within the block must be indented the same amount. Like this will give you an indentation error. Actually, Python tries to remove some unnecessary, they think that it is unnecessary, lines of code to make writing the code faster. But as my previous supervisor usually said, we don't think that writing braces or AND will take much time in the other languages, especially when you are using IDEs. They will write them for you. You don't need to write them by yourself. But if you have those braces, those words, it's, to my idea, it would be more easy to read. It would be easier to read your code, to follow the blocks, to follow the scopes. But in Python, okay, they remove that to make it faster, to make writing the code faster, but I think they make the code less readable compared to other languages. This is my opinion. You can have your own opinion, no problem. Okay, multi-line statements. Statements in Python typically end with a new line. But if you want to break one statement in different lines, you have to use the line continuation character. The statements contained within the brackets, braces, or parentheses do not need to use the line continuation character. So here it is compulsory if you want to have the one statement in multiple lines, but this one is not compulsory. You can either put this or not because it's between the brackets. In Python, you can use single quote or double quote or triple quotes to denote string literals. So, for example, in C++, one quote, single quote, is used to refer characters. But in Python, we don't have character. We only have string literals. And both of the, either I put here single quote or double quotes, they do the same. They are two different options that we have for one task. But these triple quotes is different from that one. So triple quotes here, if you, for example, like here, if I enter here, if I press my return button here while I'm writing my string, it considered it as /n. So however you write your code, it will print your code like that. Okay, for this one, I have some other slides to explain it more. I think it might be difficult to understand with this example, but there are some other examples to explain triple quotes. But you, for this moment, for this slide, you need to know that we have three ways of defining string literals, and two of them are the same, and the third one is somewhat different from these two. If you want to put a comment in your code, you have to use a hash sign. A hash sign, which is not inside a string literal, is the beginning of a comment. So if you put a hash sign here in the middle of your string, it's not a comment. It should be like this. Python does not have multiple line commenting feature. Again, that's the reason that I'm explaining, when I'm explaining this thing, I refer to other languages, because I guess some of you are familiar with other languages, and by referring to them, it makes a connection in your mind between two different languages, and you may be able to memorize them easier. So in C++, for example, we have a multi-line commenting feature with / and a star in the start and end of the our multi-line of code. But in Python, you have to put hash sign before every line. But if you are using, if you don't have to write it line by line, if you are using an IDE. In IDE, for example, in Pycharm, you can use Control plus a /, then it will write this all these hash signs for all of your codes. You select some lines of code, Control /, then it will comment all these lines. To wait for the user, I said that to to ask the user to enter something for you, you can use input function, but you had x equals input, but here you don't want to use that variable anymore. So if you put x equals input, the user enters something, and that value will be stored in x. But here I just want to run my code, and the last line of my code, in the last line of my code is written input, press the enter key to exit. What does it do? It asks the user to enter something, so the interpreter has to wait for you, and then you can check the output of your code, and it will wait for you. This is all, and you don't need to save what the user entered in any variable, because your program will end and you don't use that variable anymore. So this is the command that you can use to force the interpreter wait for you when the run of your program has been finalized. Multiple statements on a single line. So we said that we can break one statement into multiple lines by using the continuation operator, which was slash. I don't know. I usually mix a slash and back a slash. So if I'm saying anything wrong, you can understand. Now, if you want to have multiple statements in one line, you can use this. You can use semicolon. Unlike the other languages, like for example, C++, which uses semicolon at the end of every command to say that the command is done, this is the end of the command. In Python, you don't need to enter a semicolon or anything else. But if you want to write multiple statements in one line, then you have to separate them with semicolon. Variables. Let me ask you if everything is clear till now. If it is, I can go to variables. I don't know. Where can I see the chat? Python 3. Everything so clear. Okay, thanks. It's very difficult to teach online because I cannot see your faces, and I don't know if you are tired or you need more interaction or not. So I'm just teaching what should be taught. Okay. I guess you are familiar with variables, but when you create a variable, you reserve some space in the memory. But in Python, variables are somewhat different with the variables in other languages. Python variables do not need explicit declaration to reserve memory space. For example, in C++, you may say that int a equals 1 semicolon. That is the command that you use to define an integer variable. But here you don't need to use any data type. You don't need to write int. It will be done automatically by Python interpreter. So everything is done by itself. Actually, we have something similar in C++, but here it's the case for all of the things that you have. So The equal sign is used to assign values to variables. So here, this is an integer assignment. So when I write an integer value here, the interpreter recognizes that you need an integer object. If you put here, I don't know if maybe it's good to give this example. If you are familiar with C++, in C++ we have auto. That's auto is like this. So when you write auto in C++, the compiler itself will recognize the type of the data, the type of variable that you need. But here you don't even need to write auto here. So everything will be detected automatically by the interpreter. You don't say what is the type of the variable I need. It's your interpreter responsibility to recognize the type. So here, by writing this, it will be an integer variable. By writing this, it will be a floating point variable. And by writing this, it will be a string. You can also define 3 variables or more or less at the same time. And by this, you will have 3 different objects, which are not 3 different objects, 3 different variables, which are referring to the same object. Sorry. And also here you have 3 different variables, and so it's like defining variables just by using one equal sign. And like other languages, we have basic operators. Arithmetic operators are like this: addition, subtraction, multiplication, division, modulus, exponents, floor division, and you should be, that might be new, we don't have it in some languages. If it is 9 divided by 2, it would be 4, and if it is like it's floating points, it's also 4, but the result is a float. And if it is negative, it would be here -4. So it gives the floor of your division, and minus this is also like this. And comparison operators, again, we have this ones. Assignment operators, we have this, and bitwise operators. The values the numbers that you have will be converted to binary version of them, and then they will be, and then this operator will apply to them, will operate on them. And, or, XOR, not, shift, and right shift, left shift. And logical operator, and, or, and not. So the syntax is different here with other languages. In not in C++ is in I don't know what to call that, but it's used to show the estranged, or show that it's not question mark, it's this one with point. I cannot remember the name, but not in C++ is different from here. We also have 2 specialized operator which only exist in, to my knowledge, which only exists in Python: membership operators and identity operators. These operators test for membership in a sequence, such as strings, lists, or tuples, resulting in true or false. So we will see some examples of them later in next slides. And it's in and not in. Identity operators, it's is and is not. We have 2 variables. We are checking them if they are the same or not their values. If these objects, the objects that they referring to, are the same or not. And it means that they are the same if their ID is similar. I will explain the objects in the next slide, so you will learn more. And this is the basic operators with their priorities. So the highest priority goes to this one, and the least priority goes to this one. I do recommend you to use parentheses to show the priority, because sometimes you follow these rules, but some other people doesn't know cannot remember the rules correctly, or even yourself, you may hesitate that if you want to order this priority, if you want it to be like this or not. So it's better to use parentheses if you want to do in one statement. If you have, for example, if you want to do multiplication first, put parentheses around that. And if you want to do the other one, so create the priorities, the order in your statements using the parentheses. It's more readable for the user than for the programmer that wants to read your code. But it's good to know this order, because some people may not use those parentheses. Okay, we are going to learn about some special data, standard data types. These are really special to Python. They are different from other languages, and you will see they have some similarities, but we can say they are very unique in Python. So we have first, we have Boolean type, numbers, text sequence type. Sequence types, these are number or strings, anything. Mapping type, which is dict, set types, binary sequence types, bytes, byte array, memory view, and other built-in types, modules, classes, class instances, functions, methods, every other things. So as I said, everything in Python is an object. Even the classes, functions, methods, all of them are some objects. We will consider them some data types, standard data types in Python. Before digging into the details of the data types, let's see what Python objects are. In Python, everything is an object. Every object has its own data type and internal states. So, for example, when we define an integer object, a variable of type integer, it refers to another, it refers to an integer object, and its data, and that integer object has a data. The value that for example, when we print that integer variable, we print the internal states of the object that variable is referring to. The id function returns the memory location of the object, which can be referenced by a variable. How is data stored in the memory? When Python executes a equals 1000, this creates an integer object at some memory location. On my PC it was this, and stores value in value as 1000 in this memory location. Here a doesn't contain value 1000, but just holds the reference, the memory address to this object. So here I run this line of code, print a and a. I see this is this line, And now I'm printing ID of A, ID of 1000, and ID of 1500. You can see the ID of A and ID of 1000 are the same because both are referring to the same memory location. And ID of 1500 is this one. Now here I set A to 1500. By this line of code, I'm creating another object. Actually, since I called this one, this object is already created. But if I didn't use this command here, the object would be created in another, in a memory location, which is different from where 1000 is, and stores the value 1500, and A would refer to that object. So A here is different from A here. They are referring to different memory location. So here ID of A is this one, which is the ID of 1500, and ID of 1000 is still the one that it was, and ID of 1500 is this one. You may think that these are too difficult, these are not necessary to know, but in fact they are really necessary for you to know, because when you are working with Python objects in different scopes, in different functions, you may have some difficulty to find out what's happening there. Why I change a variable, but the other variable will not change. Why I change this one and the other one is also changing. So these are what why it is important for you to know what's happening in the background. In fact, Python developers wanted to make it easy for the developer they wanted to do everything for the developer in everything that is related to the memory for the developer, and the developer doesn't need to think about these things. But when you are trying to implement your code, you will notice that no, I need to know them, even if Python is doing that by itself, but sometimes you will have some difficulties. So then I have to need to know more about the Python objects and the memories. I said what is keyword is operator, but now I'm giving you some examples and how you can use that. Is keywords compares two objects and returns true if both the objects are pointing to the same memory address, else returns false. This is not the same as the equality operator. For example, here, A equals 1000. Here, an integer object is created. A is referring to that integer object. B equals 1000.0. Value is similar, but the object that is created is a float. So another object will be created and this value will be stored in that object and B will refer to that object. You can see this is the ID of A, which is different from the ID of B because the type of A is int, the type of B is float. So when I check with is keyword, if A is B, it returns false. But if I use the equality operator, if A equals to B, it's true because the value is similar, but they are two different objects. So is will check that if these two variables is referring to the same object or not. And to get the data type of a value or an object, you can use type. So here I'm defining an integer object, I'm defining an float object, and here a complex, which is also unique to Python. But it's not very common to use complex data type. And when I write this, you will see this is int, this is float, this is complex. And if you notice that everything is class, you see, even if it's int, float, and complex, they are class. So there are much more than what we see here in the background of the interpreter. Before going to immutable objects, I'm going to again ask you if you understand what is an object and what is a variable. Yeah, factorial sign. Okay. So now you know that what is an object and what is a variable. If there is any question, you can ask. I will try to explain. Okay. Reyhane, okay, you get that. Now I'm going to talk about immutable object and mutable objects. These are also unique to you in Python, and it's, to my idea, it's very important to know. But in some documents, when they are teaching Python, you will see that they don't talk about mutable and immutable. But if you go to a Stack Overflow, you will see that there are many questions related to these topics. So it's necessary to know, because when you are when you spend some time on writing your codes in Python, when you became more experienced, you will see some problems. And to understand why you have those problems, you know these. You need to learn these topics. Immutable object is an object whose internal state or data cannot be changed, and a mutable object is an object whose internal state can be changed. So I will give you some example to understand them more much better. I said that we have standard data types, and among them, some of them are mutable and some of them are immutable. Numbers, bool, strings, tuples, frozen sets are immutable, and list, dictionaries, sets are mutable. Accessing immutable objects is faster than mutable objects. Changing an immutable object is costly because it involves a copy. And let's say why. Accessing immutable object is faster than mutable objects. When you create an immutable objects like numbers, every time that you create an object, let's say tuples. Tuples are, I will explain them more later, but just for explaining why accessing, just for explaining the last two sentences, I give you a view of what is tuples. Tuples are like arrays, but they are read-only. They are immutable. So every time that you create a tuple, in the background, interpreter will get the amount of memory that you need to save that tuple for you, And if you want to change that tuple, it's impossible. And if you assign it to another tuple, another object will be created, another memory will be allocated to you. But all of the data that you have will be stored with each other. So the whole items of tuples will be stored in a queue. So you will have all of them together in the memory. So the access time is faster than mutables. While in mutables, if you have a list is also like arrays, but it's mutable, its data can be changed. But if you, for example, change a list, then, for example, if you add another item to a list, just for that item, another memory will be located, and it might not be in the same part that the other items of the list are located. So it's more like, if you have data structure in your course, I guess not, but there you have linked list. Linked list, it means that every item is referring to the other item, and they are not stored in the same location of the memory. So that's why we say that the access time for immutable object is faster than mutable objects, because the items of immutable objects are stored next to each other, but the items of mutable objects are not stored close to each other. They can be in every other part of the memory. And then we say that changing an immutable object is costly. Why? For example, we define an integer, and as we saw, a equals 1000, a equals 1500. Every time you are creating another object, and if, for example, if it is tuple, if you add an item to that, it will copy all the existing item plus the item you just added to that in another memory location to fit all of them in that part of the memory next to each other. So you need a copy for immutable objects, while for lists, for mutable objects, you don't need that. Fortunately, this lesson is getting recorded, so if it is complicated for you and you cannot understand it very well, you can listen to what I explained to you and draw some diagrams for yourself to understand what I'm talking about. So these are some examples of immutable objects: numbers, strings, tuples, and frozen sets. I will explain them in more detail in the next slides, but for the moment, just to understand how mutable objects works and how immutable objects work, I give you these examples. Let's look at these examples more carefully. This is numbers. I define this one here. This will create an integer object. I printed here the ID of n is this one. I added by 10. What happens here? The ID of n has been changed. Why? Because immutable objects cannot be changed. If you change them, another object will be created with that value. So another object is created in this part of memory with this value. For strings, I create this one towards ID of s is this one. I concatenated this string with this string, and as you can see, this is the value, the data, the internal states of the object, but the object is somewhere else, is not here anymore. Tuples. You can create a tuple like this, print the tuple, ID of the tuple is this one. I'm concatenated this tuple with this tuple, which only has one item. But what is happening here? This is the new tuple, but it has another address. So it means that here another object is created in the memory, and this data plus this one has been copied to this address. That's why we say that the access time is okay, is faster, but it's more expensive. And here, this is frozen set. We can create a frozen set like this. I think I will teach these frozen set in the next lesson, but you will learn more about them later. The ID of the this is the frozen set. The ID is this one, and I'm concatenate this frozen set with this frozen set using this method union, and this is the resulting internal state resulting frozen set, but it is in different object, in different address. Even if I'm still working with the same variable, but this variable is referring to different location of memory. Some example of mutable objects: lists, sets, dictionaries are mutable. We can add, delete, modify its contents. And let's see the examples. Here, I'm creating a list and printing the list here. The ID of the list is this one. I'm appending just one element to this list and get the ID of that. You see the ID is still the same. An object is created for 4, but the whole list is still here. So the access time is not as good as immutable objects, but it's less expensive. It doesn't need a copy because it's still in the same address. Sets, for sets, I create a set here like this, and ID of the set is this one. I add one item to this set, and still it has this ID. Still it is in the same location of memory. And for dicts, I define a dictionary like this. This is the dictionary. This is the ID of the dictionary. And this is, I'm updating this dictionary with another element, key 440. And this is, there is the data. And this one we can see is still, they are in the same location of memory. Assignments and modifications. This is another thing. I said to you that you may have some difficulties in the future if you don't know about mutable and immutable objects, because you can also, until now, we only assign some values to some variables, but you can also assign variables to each other. And if you don't know the background of them, you may have some problems. I'm showing you here how they work. But later in the lessons that I will talk about functions, you will see the effect of mutable and immutable objects there. Here I'm creating an integer object 1 and another the same integer object with and m and n are referring to that, and this is the ID of, and ID of all of them are similar because both of them m and n are referring to the same location of memory. I create another variable O and refer and set it to m. ID of m and ID of O are now similar to each other because both are referring to the same location of memory. With this one, I'm adding that I'm adding the object that m is referring to. I'm plussing that with 1. And now let's check the ID of m and o. M now is referring to another object. A copy has been occurred. 1, which was in this location of memory, has been added by 1, and another object is created in this location, and now M is referring to that. Although O was referring to M, but now O is still referring to 1, you see that, but M is referring to another location of the memory. So this is the difference between the pointers in C++ and the references and the objects that we have in Python. And to my knowledge, this is special to Python. This is unique to Python. This was just for numbers. Let's check it for tuples and lists, which are sequence types. So these are not sequence types, these are just one element, but tuples and lists have different items, and there is an order for them. They follow an order. They are not even like mapping, which we said it's a dict or sets. They are not. They are sequence types. So I'm creating, like the procedure we went through here. Now I'm creating two variables which are tuples, but the items are similar. And now I'm checking their IDs. Their IDs all are different from each other. Although tuples is immutable like numbers, but when you create like this, their ID is different. When you create a tuple of some items, it's different from the same tuple with the same items. It's different. So now F is referring to C, and I'm checking the ID of them. F and C have the same, are referring to the same location of memory. I update C by adding one element to the tuple, and we said that tuples, if immutable objects gets updated, they will create another object to put all the items in the same location of memory. So now C is this one, it gets updated. F is it didn't get updated, and ID of C is different from ID of F. Also, they had the same address of memory at first. Although C is assigned to F. Let's check it with lists. Okay, we created two lists. We check them here. Since they are sequence types, they have three different address. They are three different objects. I'm creating another one, E equals to A, and check their ID. They have the same ID in this step. I update A. Since list is it's a mutable object, then A and E will both be updated, because when you update a mutable object, it will not create another object. It will update the object itself. And so since both of them were referring to that object, they will have different values and their address is still the same. You will see the effect of these things when you are working with different scope, when you are calling a function with a variable. If it is a mutable object, if you change it inside the function, you will see different effect when you compare when you have only an immutable object. So the effect of these things will be seen more when you have different scopes. Now I'm writing all of them in the same block of code, so you can see the difference, but you may not notice the application, the effect that they have in running your program. Okay, let's coming back to the standard data types. I guess you are tired, as I am. Let's see if you understand these things. You can try now in those online interpreters that I shared with you, or I can continue teaching. We still have, I think now we are in the middle of the lesson, 1 hour and a half. You can, if you are tired, you can have a break just to try some lines of code in those online interpreter. If not, I can continue teaching. What's your opinion, guys? I'm up to what my fellow student says. If you are tired, we can have 5-minute breaks, but don't leave this. It's interesting, the class, so I can continue. Thanks. Otherwise, it's okay. I'm worried that you are tired and you don't get the rest of the things that are actually the most difficult parts of this lesson. The first lesson is taught now. Now you will just learn the data types and the class will be over. Okay, we can continue teaching. Okay, we were talking about standard data types, and but in the middle we went to know more about objects and mutable objects, immutable objects, and now we are coming back to standard data types and how we can define them, how we can work with them, how are their functions, and the rest. So Boolean type is just bool, true and false, so we won't talk about that much. It's like any other language. Numbers, we have 3 different types of numbers: int, float, and complex. Numbers, you see that I put in the parentheses immutable because I think it's really important to memorize them. Int it's a signed integer. All integer in Python 3 are represented as long integer. So we don't have long anymore in Python 3. We had it in Python 2. Python 2 has two integer types, int and long. There is no long integer in Python 3 anymore. Floating point real values, complex numbers, as you saw one example of that in the previous slides, an unordered pair of real floating point numbers denoted by a plus bj, where a is the real part and b is the imaginary part of the complex number. You can also delete the reference to a number object by using del statement. So you can write, for example, if you have a equals 1000, you can write del a, then it will be deleted. But it's not necessary to do that because, as I said in the early slides, Python has a garbage collector. The garbage collector will release the object that you don't use anymore. So you don't need to be worried about that, unlike the pointers in C++. To have a type conversion between numbers, you can use just this syntax. If x is a pointer, by putting int in the like this, then it will be converted to int, or this one will be converted to float. You should know that when you convert, since the numbers are immutable, then another object will be created, and it will the variable will refer to that object. So the ID of the variable will change. We have some mathematical constants, pi and e. You are familiar with that as engineers. And mathematical functions that we have: absolute, scale, exponential, floor, logarithm, max, min, mod, power, round, sqrt, and so this is common in other, like the other languages, we have them, but the drawback is that we don't have min here. If you want to use min, you have to use other libraries like NumPy or the other libraries. For some of these mathematical functions, some of them are inside the interpreter itself, but for some of them you should use import math, which is another module. For example, for ABS, I didn't need to import math. I could run it like this, it gives me 4. But for modef, which divides the floating points numbers like this, this one is the output of this would be this and this. For this function, I had to use math module. I had to import that. We will talk about importing and the other things in the next lessons. Random number functions with choice, random, seed, shuffle, uniform. You have some functions that you can randomly generate some numbers. You can go through the Python documentation to know more about them. You cannot memorize all of them. It depends on your experience. The more you use them, the more you learn and you memorize them. But since the only thing that you need to know is that there are some random generator in Python, and you can go through the Python documentation to whenever you need to use them. And also we have this function which sinus, tangent, and the rest. Again, you can go through the Python documentation to learn more about them. The next data type is text sequence type, str, and as we said, it's an immutable object. a contiguous set of characters represented in the quotation marks. And as I said, we have different ways of defining a string: single quote, double quotes, and triple quotes. Subset of a string can be taken using the slice operator. We said that in Python 3 we have a slice operator with indexes starting at 0 in the beginning of the string and working their way from -5 to the end. I guess in the next slide we will see more about negative slicing and more about the slicing. Python does not support a character type. These are treated as a string of length 1, thus also considered a substring. Plus sign, the string concatenation operator, we already saw an example of that when we was talking about immutable objects. And the repetition operator, you can see some examples here. Here with this one, I could put double quotes here instead of single quotes to define the same string data. And with print, I'm just printing that. This with this one, I can access the first character of this string. With this one, I can access the letter with index 2 till the letter with index 4. So 5 is not considered here. So let's see here. The first one, this one is this hello world. This is 0. So the first letter 2 till 5. 0, 1, 2 till 4 because 5 is not among them. L, L, O. 5 is this one. So 5 is not included. And if I write like this, it's 2 till the end, because if you don't write that, it would be the end. If you don't write here a number, it would be the 0 from the first till the end. And this one prints 2 times, so it's like concatenating a string with another one. You can put 3 here to have to concatenate the string 3 times. So you see that hello world, and plus is just a concatenation operator. And like any other immutable objects, item assignment is impossible. Concatenation and repetition leads to a new objects. I think you are already familiar. What is negative indexing that we don't have in any other languages except in Python? What is negative indexing in the sequence data types? What is sequence data types? Str, list, tuple, and range. So in Python, we have 2 ways of indexing for sequence data types: positive indexing and negative indexing. Positive indexing is like any other language. It's totally similar to C++, 0, 1, 2, 3. I guess in MATLAB it's 1, 2, 3. I know in some languages it starts from 1, but in Python, in C++, it starts from 0. But it also has a negative way of indexing. So if we have a string with these letters face, if has the index of 0 and also has the index of -4. It starts here -1, -2, -3, -4. Either you use this one or this one, you can refer to F. Let's see the examples. I wrote all the letters in English language here. So we have 26 letters here. I'm using 0 and I'm using -26. Both are referring to the first elements of my string. A and A. So here I'm referring to 0 until 2, which is 0, 1, and 2 is not included. A, B. I can also refer to that one via -26 to -24. We know that this is -26, -25, -24 is not included. So it's A, B. Interesting, this is interesting and strange also, that we can also do a combination of negative indexing and positive indexing. So the Python interpreter will know that when you say -26, you are referring to these elements. Even, or if you say 0, you are also referring to this one. So -26 is this one, 2 is this one. So I'm saying that from this one till this one, until this one should be printed, should be sliced, A and B again. And also I can do like this, 0, and for the bottom, for the top, I can say -24, and it also gives me, this is 0 and this is -24, and so it's A, B. So you see that I used 4 ways to get the same, 4 ways of indexing to get the same slice of strings that I need. Another thing that you should know, in Python 3 and also in some version of Python 2, I guess, we have another one, part in a slicing, which is the step that you want to use while you are slice the items from a sequence data type. So I'm saying here it's 1. So this one is similar to this, it's similar to this, and it's similar to this. This part is optional. If you don't write this part or this part, it will be considered as 1. So the default step is 1, and you can put the colon here or not. It's not obligatory to put that here. And also, if it is 0, or if it is the end of the object, you don't have to write it. So the default values in all of them, the default here is 0. The default here is 1. The default here is the last item of your sequence data type. And this, if you don't write this one, you are also, it is also possible not to write the colon. So here I'm again creating the same thing. I'm saying that this is not compulsory to write. You can remove also the colon. And this is also similar to that, because 26 is the last item, so I can also remove that one. So I can also even put the colon or remove that. It's it's optional. And let's see here what's happening. From 0 to 27, I'm saying that you show every other letters. So A, C, D. So since the step is 2, it shows me it extracts the letters like this. I don't need to even write 227 to have this one, because this is the first and this is the end of the my sequence stop, my string. I can use negative indexing for that, -2. But what's the difference? If here, if my step is negative, then the slice will be reversed. So you can see here -2 is from the end Z, Y will be ignored, X and V and the rest. So if you want to reverse one string, it will not change the object. It's just because I don't set it to anything. But if you want to print in a string, or you want to assign it to another thing, if you want to reverse it, you don't need to use a for loop to do that. You can use just a slicing, just indexing and a slicing to be able to do that. This is the advantage of Python. That's why it's very popular, that you can work with matrices and sequence data types very easily and much faster. You may not need to use long for loops. You can write a long for loop that you have in other languages just by one slicing. It's similar with what you have in MATLAB. In MATLAB, you are also it's easy to work with matrices. This is also the case with Python. This is what makes it strong to work with deep learning methods. There we have large data sets, large matrices that we can modify them, access them through this slicing and indexing. We will learn again more about these things in the future when we are talking about loops. Okay, let's come back to strings again. We have escaped characters, we have string formatting operators, and the common ones C, S, F, and D. This is characters, this is a string, this is floating. So you can learn more about these things for yourself. This is where I said to you I want to talk about triple quotes. 3 consecutive single or double quotes can be considered as triple quotes. And this allows strings to span multiple lines. You can see here I just press my return button in my keyboard and I wrote these lines of codes. Either I put a /n or /n, I don't know, or if I put just if I write my text like this, both are doing the same, and the output will be like this if I use these triple quotes. Okay, but if I only use double quotes here or single quote here, then first of all I cannot press enter here, because we said that to have one statement in different multiple lines, we have to use continuation operator like this. And the problem is that it will consider all of them in one line. You see, when I print this one, you cannot see the rest because it was outside of my screen, outside of my screenshot. And so these will not act as enter anymore. If I want to have enter here, I have to add /n here to have an enter. And what else we have here? I said that we have some escape characters. /n is new line, some other thing, /odd carriage return, /t tab, and some other things. The common ones are the ones that I made them in blue. So you can also use this one. If you write this like this, it says it's like an escape character that I want to write a / here. So it won't show the first one because this is just like a /n. This is supposed to just print one slash. But if I put R here, it means that it's raw data. I want to show all here. So there is no escape character here. We have many building string methods here. I wrote some of them that are more commonly used in Python. Again, you don't have to memorize the syntax of this function, but you should know that there are some functions like this, and while you are implementing your program, and you should go to the Python documentation, find them instead of implementing them yourself. As I usually say, if there is some built-in methods, you should use them. Why? Because they are standard methods. They are memory efficient, they are CPU efficient, and there is not any bug with them, so they are stable. They are more stable than the what you will write. So it's better to use standard libraries instead of implementing them by yourself. Except the moments that you need a special behavior that is not implemented in the standard library. Counts how many times str occurs in a string and in a substring of strings if a starting index beg and ending index and are given. It starts with, the name says, determines if a string or a substring of a string it starts with the substring str and returns true if so and false otherwise. Ends with, if the strings ends with that substring, find, it checks if there is that string in that, if that substr exists in that string. Index, it's similar to find, but it raises an exception if str not found. Replace, you can replace part of your data with the part of your string with the other one. And you can also split. This one is very useful. You can split your list with some substrings and some other things. Lower is title, join, upper is digit, is all alphabet and numbers, capitalize. We will see some examples here. Like here, I said count L. So in this text, the number of times that we see L is 4. And I'm saying that here from this index, count the number of L's that we have in the text. So it's 2, 5, 0, 1, 2, 3, 4, 5. 5 is here. From this till the end, we only have 2L. That's why it's 2. It starts with W, so it's false because it's. I said that Python is case sensitive, but for this one it's false. Let me see. 1, 2, 3, 0, 1, 2, 3, 4, 5. Okay, 5 is here. It's it doesn't start with W. I should put 6 here to get true here. And find, we'll check L. The first occurrence of L is at the index 2, and this one also gives the same. And I'm saying that replace the word world with Nasi, and as you can see, I get hello Nasi 1 and Nasi 2 instead of that. And I'm splitting this one, and the default delimiter is a space. As you can see, it's splitted to, and it returns a list of strings. And here I'm saying that the delimiter is a space, but give me 3 times, so at least 3 times, so it gives us this. And for this one, I split the text and then I'm using join, and with this character, and store it in another object, and with this variable I'm referring to that object. So this list is joined together with this delimiter. And here I'm checking this function. This function says that if the string has only alphabet and numbers, or it has the other thing, so it's false because it also has these escape characters. But this one is true, it returns true because it only has alphabets. So let's go to the list, but before that, is there any questions? Are you following me really? Backslash and a slash, thank you, but I won't memorize that, I can't. It's interesting, the class. Oh, yeah. Backslash, slash. I can't memorize that. It's I'm.
Everything is clear for me, ma'am.
Okay, thanks. It's good that you are following. If I were you, I would be really tired. It's very difficult to follow a class that is online like this, and the teacher always talking. Okay. Let's go to the list. I said here str sequence type, but this sequence is different from this one. But they have very similar. For example, the slicing operator and the indexing is very similar in str in the text sequence type and the other sequence types. List, tuple, and range. Now I'm going to talk about lists. Lists are mutable. We talked about that. A list contains items separated by commas and enclosed within a square brackets. You saw that some examples of lists already, so you know that what are they. All the items belonging to a list can be of different data types. Unlike what we have in C++, in C++, if you, for example, you will define a vector of integer values. So there you have all the items of the that vector are of the type of integer. But here your list can have any items from any data type. The slice operator here with indexes starting at 0 in the beginning of the list and working their way to the end. And the end is -1, and sign operator is the concatenation. I mean, plus sign is the list concatenation operator, and asterisk is the repetition operator. The elements and the size of a list can be changed because it's a mutable objects. Built-in list functions are this one, len, max, min, list, and it will convert, for example, a tuple to a list. We said that tuples are immutable objects. But again, when you're converting them, it doesn't mean that that variable is changing. Another object will be created. Built-in list methods are append, count, extend, index, insert. You can go through the documents to learn more, but I provide you here with some examples. So I can define a list like this. It has strings, it has numbers. So the items are not, it's not compulsory to have a list of the same data type. Another list is defined here like this. I'm printing my list here. This is that one, and I'm using len to get the number of items that we have in my list, and it's 5. And my list 0 and my list -5, we had this example with strings, and I said that this is the case for all sequence data types. So with 0 and -5, I can refer to this one. Both are saying the same thing. With all these 4s, I can have access to B till sorry, to the item. I made a mistake. So from for this one, 1, 2, 3, I can have access to 1, 2, 3. 3 is not included. 1 and 2. You can see here it's 1 and 2. But with these indexing, with these indexes, I can also have the same part of memory, because we said that 0, 1, 2, 3, 4, and -1, -2. So every item of the list has 2 indexes. And also I can use this way of indexings and slicings, and you can see they are working the same. And here I'm using this operator to have to concatenate list multiple times, 3 times, and you can see that it creates a list with this one, which is concatenated 3 times. And I can also concatenate 2 lists together, and you can see these 2 together. And I can use in and not in to check the membership. I can say that John in my list is true, and John not in my list is false, because it is. I'm asking that if John is not in this list, and it's false. And I'm printing the ID of my list and my list here. I'm updating, concatenating an item to that, and it's sorry. Oh, okay. I can update one item of the list with this one, and it was 1. It changed to 5, but the ID is still the same because it's lists. And so here you can see that I can update the items of a list, because it's a mutable, yes, it's a mutable object. So I can update that, and the object is still in the same location of memory. I can also delete one item of the list. So I delete this one, the 3rd one, and it's deleted from here. The index too, not the value. This is just the index. It's just an accident that they have the same value and the same index. I mean, 2 has the same value and the same index, but it's here you should refer to the index. And I can delete that. 2 is deleted here, but still the list has the same ID. It's still in the same location of memory. We have 3 ways to remove an item from a list. Consider that we have A like this. We delete A2. This one deletes A2. This will be deleted. So 2, 5, 4, 3, 2. This one has been deleted. And again, I have A like this. I remove 2 here is not the index. 2 with remove is the value So it will remove the first occurrence of 2. So it would be this one, and the list would be like this, 5, 2, 4. The first occurrence of the value 2 will be removed. And for this one, a.pop 2, this is an index, and it will remove this one, as you can see, but it will also return the value here. So if, for example, if it was 5 here, item will have 5 inside that. Okay, yes, here. Item will have 5. So again, this is just an accident that the item with index 2 has the value of 2. So these two, I think I should have given another example with other values. It might be a bit confusing, but you should know that for delete and pop, you should use index to delete one item, and for remove, you should use the value. For pop, if you use the index to remove something, it will pop it and put it in another variable. The error that they will provide if an error happens is different from each other. For example, here I'm saying if there is any item with the value of 7, the first occurrence of 7 should be removed from this list. Since there is not any, it gives me a value error. It says that you can see the error is very clear. X is not in list. The command is list.remove x, and x is not in the list. And what is x? X7. And for this one, I'm saying remove the item that has the index, that its index is 7. And it gives me an index error, list assignment index out of range, because this list only has 3 items and 7 is not one of the indexes. And here with pop, again, I'm giving an index, and it gives me another, again, an index error, pop index out of range. So you can read the errors, and the errors, I can say that the errors most of the time are readable, are clear. The next one is tuple, and tuple is immutable. List was mutable, tuples are immutable. A tuple consists of items separated by commas. Optionally, you can put these comma-separated values between parentheses. And like here, I put parentheses, but it's not compulsory. You can remove that and just write these like with commas. Optionally, you can write also tuple before these parentheses. You can here write tuple. Here for the list also, you can write list here. But then for the list, you have to also put parentheses. Parentheses plus brackets, so both of them if you put list here. But for tuple, you only need to write tuple with parentheses. But you can also remove this one, it's optional. To write a tuple containing a single value, you have to include a comma, like this. Even though there is only one value. It's only one value, but you have to put comma. Otherwise, it will consider that as an integer value, for example, if you don't put it here. An empty tuple is like this with parentheses. All the items belonging to a tuple can be of different data types, like lists. In the list, we also have a sequence type that has items from different data types. And the slice operator acts exactly like other sequence data types, like list and like strings. Plus sign is a concatenation operator, and this sign is the repetition operator. tuples cannot be updated. I said that tuples cannot be updated because they are immutable. Tuples can be thought of as read-only lists. So they are very similar to lists, but they are read-only. They are immutable. So for example, here I'm creating a tuple and I'm creating the same thing as list. I can have this one, item assignment, for list, but I can't have it for tuple. It gives me a syntax error. Sometimes with immutable objects, if you change them, it will create another object for you. But this is not changing the whole object. This is not changing the whole tuple. This is just changing an item of the tuple. But this one is not allowed in Python with tuples. So item assignment is not possible. Item changing is not possible for tuples. And if you change the whole tuple, another object will be created. Let's see the rest. So the example here. This example is exactly similar to the examples that we had for lists. I only changed the variable names and the way that I define this one to make it a tuple. Okay, so all of these things you have seen with list can be done also with tuples. But now these lines cannot be done. I cannot change an item. It's impossible. I cannot delete an item of tuple. It's impossible, while I could do this for lists. But I can update. I can delete the tuple itself. So this one is possible. And if I print this one, if I print the variable, the object that I just deleted, it will give me a name error. My tuple is not defined because you just delete this one. Tuples also have some built-in functions like CMP, len, max, min, and tuple. With this one, you can convert a list to a tuple. The last item of sequence types are range. Range are immutable and they are very commonly used. For example, if you want to use a for loop, this is the only way, not the only way, this is a common way, the most common way to use a for loop. We said that in Python 2, we had X range, and in Python 3, it's renamed to range. And in Python 2, we had range. This range is not that one because it's just a rename of X range. Represents an immutable sequence of numbers and is commonly used for looping a specific number of times in the for loop. You have two different constructors. If you are already familiar with classes, you know what I'm saying by using the word constructor. Constructor lets you define a class, create an instance of the class. So here, range is a class. This create, like here, I can call the constructor of the class to create an instance of the class. We will talk about classes later, but just for the moment to know that what does it mean. We have two different constructors with this definition: stop, start, stop, and a step. And if a step is positive, here the numbers will be generated by this rules, and if the step is negative, the item will be generated like this. Ranges do support negative indices, but it is not common. let's see some examples of that and then come back to this. Range 10, let's see the next system. Okay, I have it. Range 10, it will, I'm converting a range to a list, because otherwise it will, if I print range 10, it will only show me range 10. It's a class of range 10. But because this is the case in Python 3. In Python 2, it was somewhat different. To see the elements, the numbers that is generated by this generator, I convert range 10 to list, and I see the values here, the list. So 10 will generate numbers from 0 till 9. And if I say I want a range from 1 to 11, it will generate 1 to 10. You see in Python, usually when you say the last index, when you set the last index will not be considered. And it's like until, it's until that one. That index is not included. So it's to start from 1 till 10. And I'm saying here from 0 till 30, and the S step is fine. 0, 5, 10, 15, and the rest you can see. And here 0 till 10, and the step is 3. So you can, if you are familiar with fors, you can understand where then you can use this range in a for loop. And it also, I said that its ranges also support negative indexes. I'm saying from 0 till -10 and with -1. So it goes from 0 till -10, -10 is not included, with the step -1. This also is useful for your loops. And range 0, it gives nothing. It's just if I convert to a list, it gives me an empty list. And also this one, because I'm saying that from 1 to 0, there is nothing, it's wrong. So it gives me like this. So the advantage of range type over a regular list or tuple is that a range object will always take the same small amount of memory, no matter the size of the range it represents, because it only stores the start, stop, and step values and calculates individual items and sub-range as needed. So you see that I use list to see the numbers, because a range object only has a only has start, stop, and step values. It doesn't have any value. It doesn't store any value. It has just a rule for itself, and when it is needed, it will generate the numbers. So then it will take less amount of memory compared to this list. So some other examples. We have range 5 here, and I convert it to a list and print that. As you can see, I use in and not in for in the range. Print one in range. You don't need to change it to list. It in and not in can work with range as well. So it's true. It's 5 not in range is true because 5 is not in range 5. You can see 0 till 4. I created an object of range 5 and set its reference to a variable. If I print A1 like other like list, it will gives me this one, the item, the second item of the list. Although it is not a list, it doesn't store this one. It will, whenever I refer to that, it will calculate this. It didn't store these numbers inside that object. Only step and start are stored. And a.index, you can also refer to that one. A-1, you can it will refer to this one, and also the other slicing ways of that. If I refer to a 0 to 2, it will not generate. It will not print the these. The items. It will give you a range that can generate these lists for you, 0 to 2. It will says to you that it can be generated with this one. So it's again a range, and for range 0, it's empty because it has nothing. Because the default value of the step is 1. The maximum. With this one, you are saying the maximum is 0. The minimum is also 0, so it's nothing. With this one, it also gives you an empty because it's the max is lower than the mean. Here it was also the case. Max was equals to the mean, and you can also use operations like this to compare them. This will tell you that these are this is true because both generate empty range. And with this one, I'm creating this, and with this one, I'm creating this, and I can compare them, and it gives me true. And also for this one, I can also compare the range themselves and also the list. I can compare the list, and it will compare all the items of the list together. And the dicts, let me check. I think this is the last one, I hope. Yes, and then after that, yeah, this is the last 3 slides that I'm going to teach are dicts, and then the rest will be remained for the next session. I will give you also some exercises. If you like, you can do that. So the other data type that we have till now, we got familiar with lists, strings, tuples, numbers, and now we are going to talk about and also range. And now we are going to talk about dictionaries. It's a hash table. It's mutable of unordered key value pairs and enclosed by curly braces. So since it's unordered, we don't have slicing, we don't have indexing that we have for sequence data types. And to use them, I will show you how you can use that. A dictionary key must be of an immutable data type, such as strings, numbers, or tuples. But the values, on the other hand, can be any arbitrary Python objects, either standard objects or user-defined objects. Values can be assigned and accessed using square braces. Built-in dictionary functions are like the other one, len, str, type, compare, and the methods. What is the difference between functions and methods? I should delete this one, but function and method. Functions are working, the input of the arguments of the functions are dictionary, for example, here, because we are talking the dictionary functions, and methods are, you can have them like the name of the tuple, point, and the name of the method. So the input is not a dictionary. You can have access to them through the name of the tuple. clear, copy, get, ASCII, items, keys, updates, values. So these are really good methods that you can use them when you are working with dictionaries. And again, you can go to the Python documentation to see their syntax. So to define a dictionary, you should use this one, or you can also use like this. I mean, you can either put the items like this inside the, that while you are defining that, and or you can add item like this. So I'm saying that my dict1, this is 1. So I'm adding a new entry to my dict, which whose key is 1 and whose value is this is 1. And it's, again, it can be of any type, but the only thing that is important is that the key type should be immutable, immutable, and the value can be anything. And here on my dict1, it will print value for 1 key. And with this one, it will print a value for 2 key, which is this is 2. And tiny dict, it will print the whole dictionary here. And dot keys, it will print only the keys, and it gives a list of the keys. You can see this is the list of the keys, but it's in dict keys. Dict keys also are a data type in another objects. So it's dict keys of these links. I think if you dict keys will have a .to list or something, a method like this, to get the list from that. But now it's the type is dict keys. If you call keys here, if you call values, it gives you an object whose type is dict values, and the items is like that. I guess again here you have .to list or get the list. So you know, I also don't know all the methods, but I can guess there might be methods like this. So before implementing, for example, I can convert this one through using a for loop to a list. But why I should do that? Before doing that, I should check the documentation, or I should check the if you are writing the code using an IDE, the whole methods can be seen for you, can be shown by you, by the interpreter, sorry. And so you should first check the built-in functions, built-in methods before implementing something for yourself. Because you know, these are something that all the people are using. So when something is used by most of the people, probably it's part of the standard library. It is implemented already. You don't need to write yourself. And it's better not to write for yourself. You can also remove an entry with key name. I said that for tuples, you couldn't do that because tuples are immutable. But here you can do that. You can delete one entry. You can also clear the whole items of the tiny dicts, and it will gives you, if you print that, it will give you just an empty dict. And you can also delete the tiny dict, delete the entire dictionary. Till here you had the dictionary, you had that location of the memory, but when you do this, the object will be deleted itself. So after this, you cannot call print tiny dict. If you call that, it says that there is not any tiny dict in your program. So here I'm again creating a dictionary and print dict name. I can print that like this. It will just give me the value of this entry. Name was Zara, so it will give me name. Oh, okay. Okay, this is a bug here. There is a bug here. So I'm creating two entries with the same key. You see here name Zara and name money. So name here is the same key as here, and the last one will be considered. You won't have two entries with the same key. The last one will be considered. So if I print this one here, it would be money. My dict here, I'm creating another dict here, but it is impossible. Why? Because here I'm using a list as the key. This is a list. And we said that for the keys, we have to use immutable objects, and the list is mutable. So it's impossible, and it gives me an error like this, type error, unhashable type. We said that dictionary is a hash table. So, and we said that for a dictionary, we had an immutable object as the key to be able to define the dictionary. And it says that list is not hashable because it's immutable. Okay, we have some exercises here for you. I suggest you to do it at home or now. You still have a half an hour. I can be here present and you can do the exercises here, or you can do it at home. I recommend you to send your exercises to my email. I can check them for you. I can say that I can say that I can be very. You will have some fast replies from me, but I will check them and I will tell you if they are correct or not. This course doesn't have. Let me stop sharing my screen. Or no, I think it's better not to stop. Okay, I can see some questions. No question for me. It's clear, thanks. Yeah, but you make this interesting side on your time. Okay, thank you. What is pop? Oh, okay. Sorry that when I'm sharing my screen, when I'm showing the slides, I can't see any message from you. So sorry that you sent a message 20 minutes ago, but I see it now. Do you know what is pop now, or you need me to explain more? Rayhane, I'm talking to you. Is Rayhane here? Okay, let's go to the pop. Where was pop here? I don't know if you have if you know anything about stacks. We have a data structure. This is a data structure. It's not related to. It's not special. It's not unique to any languages. Every languages have this data structure. So it's a stack. In a stack is like it's like a glass, and everything that you put in the stack will be at the end, and you can push something to your glass, and you can pop something from that. So you can usually it's like that for the stack you can push from the top and you can pop from the bottom. But here we have a list. It's not a stack, but the term is similar to that. We have a list here, and we are saying that with push, we put, I said for stacks, with push, we put some items to our stack. And with pop, we get some items from the stack. So if I put 1, 2, 3 inside my glass, and to put them, I should push 1, push 2, push 3. And to pop them, I should push 1, push 2, push 3 again in the same order. And for them, so the order was like this. But here we have list, and we want to pop them. So what pop does is like removing the item, but it will not throw it away. It will let you to save it somewhere. So here I'm saying pop 2. 2 is the index. I'm saying that give me the item with the index 2 and remove it from the list. Give it to me, I will keep it. Okay, so if it will remove this item with the index 2 and give it to me, and I will save it in item. This is my responsibility what to do with this item, but it will be removed from the list. But here they only remove them and they will throw them away. They don't give it to you. I guess it's clear now. Okay, very good. So what is your suggestion? Do you want me to share the exercises with you now and you want to do it now? Or you feel tired and you want to do it at home and send it to me? Again, you don't get any scores for this course. This is just a catch-up course. I know I'm teaching that's in more depth and it's really like a course, but it doesn't have any score. The only thing that brings you to this class is your motivation. Just this, because there is not any scores, any obligation. So what's your suggestion? Share, you want to do the exercise now or you want to do it at home and send it back to me? Mail it to you, okay. Okay, so I think, should I share the, this is the first time that I'm using Teams. Should I share the slides and the video here